Using the Ti-84 graphing calculator to evaluate a definite integral. Southwestern College, Professor Maria Olivas. In this video, I will be showing you how to use the Ti-84 plus CE graphing calculator to evaluate a definite integral. We will be evaluating the following definite integral. The integral from -1 to 2 of -x cubed plus 3x plus 5 dx. First, we need to input the integrand function into the graphing calculator. The integrand function is f of x equals -x cubed plus 3x plus 5. So first we're going to press the y equals button. Now we're going to input our negative. Make sure you press the negative button and not the minus button. X raised to the third power. And now we want to press the right arrow key in order to get out of our exponent. Plus 3x plus 5. So if we press graph, we're going to see the graph of the function. So here we see a cubic function that looks like it has its y-intercept at 0, 5, and the coordinate plane extends from -10 to 10 on the x-axis and -10 to 10 on the y-axis. Let's go to second and calculate. And on the calculate menu, we're going to choose number 7. It says the integral of f of x dx. Here we see our calculator screen displaying the graph of the function f of x equals -x raised to the third power plus 3x plus 5, with the cursor on the y-intercept 0, 5. The x-axis extends from -10 to 10 with a scale of 1, and the y-axis extends from -10 to 10 with a scale of 1. In the bottom of the calculator screen, it says lower limit with a question mark. It also shows x equal to 0 and y equal to 5, which represents our y-intercept. It's going to ask first for our lower limit. Our lower limit is -1, so we're going to type that in. So it says x equals -1. Now we're going to press enter. Then it's going to ask for our upper limit, which is 2, so we're going to press 2 and enter. Here we see that it graphs the region bounded by the function and the x-axis over the closed interval from -1 to 2. It shades it in a darker color. And it's going to provide us with the definite integral of this function. So here it says the integral of f of x dx is equal to 15.75, and that represents square units. It represents an area, because we can clearly see here that our area is going to be bounded by the function and the x-axis. Let's go ahead and get a better view of this. I'm going to press the window button and I'm going to change the x-min. I'm going to change the x-min to -2, then the down arrow key, change the x-max to 3, and then the x-scale, we're going to keep it the same, so just go ahead and press the down arrow key. Y-min is -1, and the y-max is going to be 8. And we're going to keep the y scale the same. Go second quit. Now we can go back to graph, and this gives us a much nicer picture here, a more zoomed in picture. Here we have our calculator screen displaying the graph of the function f of x equals -x raised to the third power plus 3x plus 5, where the x-axis extends from -2 to 3 by a scale of 1, and the y-axis extends from -1 to 8 by a scale of 1. We're going to press second calculate and repeat our process. So lower limit was -1, enter, upper limit was at 2, and then we press enter, and that gives us our area that's bounded by our curve and the x-axis. This window gives us a better view of the region bounded by the function f of x equals -x raised to the third power plus 3x plus 5 and the x-axis over the closed interval from -1 to 2. Here, our coordinate plane has an x-axis that extends from -2 to 3, and the y-axis extends from -1 to 8, both by a scale of 1. At the bottom of the calculator screen, it states that the integral of f of x dx is equal to 15.75, and then below that, it states the closed interval from -1 to 2. Another way to find this integral would be to go to, let's go second and quit. We're going to press the math button, and we're going to press number 9 where it says FNINT for function integral. So we want the integral from -1 for our lower bound to 2 for our upper bound. And then inside the parentheses here, we need to put our integrand function. So I'm going to type in our integrand function, which was -x raised to the third power and plus 3x plus 5. And then we're going to press here dx. Enter. And we get 15.75, which is exactly the same answer we had gotten before. Another way to get to this function, if we don't want to go through the math button, would be to press the alpha button. The alpha button is going to be the green button that's right below the second key. I meant the alpha, sorry. Alpha, and then we're going to press the window in order to access that F2 function. We want number 4 where it says function integral. So we're going to press 4. And we're going to type in everything almost exactly the same. So our lower bound was -1. Our upper bound was 2. We're going to press the right arrow key to get inside the parentheses. Here, instead of typing in the entire function, I'm going to go to vars, V-A-R-S, because we already typed in our function for y sub 1. And I'm going to scroll over to the right to y vars and press enter on number 1 for function. We're going to press enter on number 1 for y sub 1, and then the right arrow key, and then type in that dx. And we get enter, and we get 15.75, exactly the same, but a slightly different way of achieving that answer. All right, let's press the math button. And if I go to answer to fraction and press enter, I get 63/4. So I can also get this answer as a fractional answer. If I want it as a mixed number, I can go to mode and I'll press the down arrow key until I get to where it says fraction type. And then we're going to go right arrow key to where it says UN and then divided by D. Press enter and then go or press second quit, and then we can press enter. I believe we can press enter again, and yes, this will give us our answer in the form of a mixed number, 15 3/4. So you can get your answer any one of those 3 ways, whichever way you want to write out your answer.